जो नहीं आ रहा है
Dr. Viru Prakash, I think we are good to go. We can start.
Okay. Very good afternoon to all, and to the speakers and the participants. I welcome you all on the second day of the webinar, COVID-19 pandemic, crisis and aftermath. Yesterday, four speakers, Dr. Anil Arora from Sir Ganga Ram Hospital, New Delhi, Dr. Dheeraj Gautam from Medanta, the Medicity, Gurgaon, the Venkatesh Udupa from Glenmark Pharmaceutical Limited, Mumbai, Dr. Bhojraj Singh from IVRI, Bareilly, help us in gaining an in-depth understanding on the pandemic and also in clearing our doubts. I pray that today's webinar will help us in furthering our knowledge on the topic. Now, I take this opportunity to welcome today's distinguished speakers, Dr. Mamun Il Mehtab, Chairman, Department of Hepatology, BBS, Medical University, Dhaka, Bangladesh. He is also visiting professor, Department of Gastroenterology and Metabology, EHIME University, Japan, and adjunct faculty, IUMS, Iran. Dr. Abbas Ali Mehdi, Professor and Head, Department of Biochemistry, King George Medical University, Lucknow, and former Vice Chancellor, ERA University. Professor hepatopathologist, trained in GI and liver services in pharmacy in Edinburgh and founder Yangon Gastrointestinal and Liver Center, Yangon, Myanmar. Next, Dr. Prasant Kumar, Assistant Professor, Amity University of Virology and Immunology, Amity University, Noida, and Dr. Manjur Ahmad. Assistant Professor for this webinar. Without taking now slide please, slide of the chairman. Actually, the Dr. Yasodhara Verma, one of my faculty member, is actually having the problem of networking. Therefore, I am going to introduce the chairman of this technical session, today's technical session, Dr. Vechan Sharma. Dr. Vechan Sharma. Biodiversity, drug design and development, and missing. About 200 research papers. The visiting
Sharma, I think you
USA
can
for
take it up.
Senior Scientist Fellowship 2014-15 in Biochemical Sciences under Is there audible?
Yes. Uh, Chairman,
Audible?
sir, Dr. Vijay Sharma ji.
Yes,
Over to you, sir.
sound is coming very is is
Yeah,
not
you're
continuous, interrupted, continuous. Yeah, interrupted. Yeah, it is interrupted.
continue. Audible?
Dr. Viru Prakash, can you introduce the chairman again? Thank you.
Okay, okay, once again. Now I would like
Yes.
actually one of my colleague, Dr. Yasodhara, but some
बात
network
बात
failure of today's
वो बुला
Yasodhara
वो बुला रहे हैं
session, and
पांडे जी
he
की
is
आवाज आ
Professor
रही
Vechin Sharma, sir, and
है
first and audible,
वो
sir,
कनेक्ट
any
हो गया
problem?
ना हेलो वो बुला रहे हैं
Sharma ji, please go ahead.
हेलो
Sharma sir, please go ahead, sir.
हेलो
Yeah,
यस यस
Sharma ji, please go ahead.
कम और कर दीजिए सही आ जाएगा यस यस there is some problem with the sound I think
Sharma ji, can you hear me?
okay now I'm yeah it is okay now
Yeah, yeah.
okay
Now
so
there is no problem, I think.
I yeah I think it's okay so I really yeah I think it's okay and particularly Professor Viru Prakash ji, Dr. Yashodhara ji, and his entire team members for giving me this opportunity to chair this technical session of the international webinar on COVID-19 pandemic crisis and aftermath. Also thank the this great institution located in Naini, Allahabad, initiative on this pandemic and to create a generate kind of awareness among the people as to how to keep their life safe. I welcome on behalf of the institution and by virtue of being a chairperson of this technical session, all the learned speakers and whosoever is listening to the wonderful audience of this pandemic webinar. So with all this, I would request Dr. Yashodhara ji to take over and to proceed for calling the speakers one by one. And one more thing which I failed to inform the learned speakers that they should take only 15 minutes for their presentation and after that it will follow for 5 minutes towards discussion. So thank you once again and over to Dr. Yashodhara.
Sorry, Chairman sir, Dr. Yasodhara is not online. So
Okay.
I get this privilege to introduce the first speaker of today's webinar. And he is Dr. Mamun El Mehtab. He is Chairman, Department of Hepatology, BBS, M Medical University, Dhaka, Bangladesh. He graduated in MSc in Gastroenterology from University of London in 1998 and
And by
subsequently
virtue
did
of
his
speakers
MD
and whosoever is listening,
from
wonderful
Bangla
pandemic webinar. So I would
Bangabandhu
request
Sheikh
for calling
Mujib
the
Medical
speakers,
University in
on the
2006.
learned speakers that they should take.
He is a fellow of the Royal College of the Physicians of London, Royal College of Physicians of Ireland, and Royal College of, not visible to me, and American College of Gastroenterology. He is a visiting professor at the Department of Gastroenterology and Metabology University, Japan. He is an adjunct faculty Primordial Prevention of Non-Communicable Diseases Research Institute, Isfahan, and he is a principal investigator of the phase 1, 2, and 3 clinical trials of NASVSC, a new generic for chronic hepatitis B. Professor Mehtab has compiled six books related with the hepatology and hepatopancreatobiliary disease. Over to Chairman, sir.
So shall I start sharing my slides, please?
Please go ahead, sir.
Okay. So do you see my slides?
Yes, sir. Yes, sir.
Okay. So thank you very much. Firstly, I would like to thank the organizers for giving me this unique opportunity to get to you and share my opinion or my perception of COVID-19. I would like to start by remembering a quote from great Rabindranath Tagore. Tagore wrote the national anthem about Bangladesh and India. And when he founded his famous university in Shantiniketan, he said that university should be a place where we should nurture knowledge, and the emphasis should be on generating knowledge rather than distributing it. The university should be a place where we should generate new ideas, and it should not be a place for teaching students only. That was his perception. Anyway, so let's go to this main part of the talk. These are the slides that you all know about. The SARS-CoV-2, the severe acute respiratory syndrome, coronavirus 2, is a virus that was found in bats, and then last year, late last year, we had the first cases in Wuhan in China. And this is how we think is the intermediate host, and incidental host is humans. And we now have human-to-human transmission. So this is not the first coronavirus to infect humans. We have had two major outbreaks of bat origin coronaviruses, and we also know about that very well. The question is whether human beings are the final host for the coronavirus or not, and that remains a million-dollar question that needs to be answered. The challenge that the medical science faces today, whether these humans are the final host. And when we go on to the transmission, again, we know that it is transmitted by all these mechanisms. There is some confusion about fecal oral transmission of the virus. The latest controversy or the question that has arisen is whether it is a aerosol airborne virus or not, whether it is by droplets only. The recent evidence, when certain number of scientists raised the question, who has also admitted it. So why we now gather is that it is not only droplet borne, it is also airborne virus, and perhaps remains in the air for certain time after a patient infected with SARS-CoV-2 exhales the virus in his breath. There is not too strong evidence to accept or refuse it, but for the time being, this is a matter of important consideration, and we should always keep it in mind, and therefore masks should be our first and foremost priority in preventing this thing. So as you can see, there was the virus started in journey from the state of, from the Hubei province in China, from the city of Wuhan, and it then spread rapidly from this fish market in Wuhan to the rest of the world. The modern air traffic facilitated its spread, and the entire world within a few months turned red with the virus. So I won't go into details. You know this better than me, how the virus enters and how many organs it involves. Initially, it was thought to be a disease of the respiratory tract only, but we now know that hardly any organ in the human body is spared. The last, so this is again a list of the organs that are affected. We know that the ACE2 receptor is the receptor by virtue of which it enters human cells. But again, another million-dollar question is that ACE2 receptor is a known receptor that we know of, but there may be other receptors yet to be identified that may allow SARS-CoV-2 to enter into human cells. The latest organ to be added to the long list of organs targeted by SARS-CoV-2 is the liver. And being a liver specialist, I thought that I should share this slide. This is a recent paper by the Asian Pacific Liver Association. They had commissioned a task force to see or study the status of coronavirus disease involving the liver in different parts of the world. So 13 Asian centers collaborated, where we have now seen that in patients with liver cirrhosis, if they have COVID, the mortality can be very high as 43%, and especially liver cirrhosis patients who have diabetes, who are obese, are at higher risk of fatality. So yes, liver is also a target organ, and patients with bad liver disease may have a bad outcome with it. So it was our great fortune to be part of this task force and contribute to this data. So it's now up to this part, we know that it is a new disease that came from bats, suddenly started its journey from Wuhan and spread to the globe. So now what do we deal the virus with? What is in our armory? So there's a long list of drugs which are now on discussion. But the $1,000 question is, are all these drugs truly antivirals for COVID-19? And the $1 million question may be whether antivirals do have any role. Especially, do we know whether the viral load in COVID-19 impacts on its pathogenesis? So these are the questions that we need to answer. We are running after antivirals today: hydroxychloroquine, tomorrow ivermectin, favipiravir, remdesivir, and so on. But whether these drugs are at all antivirals for SARS-CoV-2, whether we need these antivirals, and whether the virus has direct significant cytopathic effect on the human body or not. So if you look at this the figure, you will see that in the initial stages of the disease, yes, the virus has a role to play. But in the later stages of the disease, when patients actually sink, when they develop demand for oxygen, when they develop shock, multi-organ failure, and some eventually die, it is perhaps not the virus, but possibly the host inflammatory immune response that plays the role, the much talked about cytokine storm. So it is possibly the cytokine storm that plays the role in getting people's worse than the viral response itself. And that is why, if you look at this slide again, I have ticked 4 drugs and not the later ones. And none of the 4 ones are actually antivirals, but these are possibly the ones: oxygen supply, rivaroxaban and enoxaparin, which are anti-coagulant agents, and dexamethasone, we all know it's a steroid. These are possibly the agents that are saving lives, and not possibly the antivirals that are much talked about these days. So let's see why I say about what the recent literature says about the much talked about antivirals. So remdesivir is considered to be a wonder drug. Everyone is running after this drug. And what does the New England Journal of Medicine article say? It says that remdesivir at best shortens the hospital duration in number of COVID patients. There is no clear-cut evidence yet that it prolongs survival. And if we go to the much talked about Japanese Fujifilm drug, or the Avigan, which is also now produced in my country and many other countries, a very recent press release says, it's on July 10, publication in Asahi Shimbun, that the clinical trial of Fujifilm Holdings has yielded inconclusive results, whether or not favipiravir effect helps the patients or not. So remdesivir shortens the hospital stay, and Fujifilm themselves are not clear whether favipiravir is at all a drug or not. Hydroxychloroquine was a drug that was very high, much talked about in the initial days, but subsequently is now out of the picture. But something very interesting happened with hydroxychloroquine. You see, Lancet had actually published an article that showed that hydroxychloroquine had significant adverse events and was not so useful. But subsequently, Lancet had to retract the paper. Because there was some protest, especially from Indian scientists, who said that the data were not properly validated, and actually the authors of the paper failed to defend an independent audit of their data. Interestingly, after that, WHO has now said that hydroxychloroquine should be discontinued. But if you look carefully at the WHO statement, you will see that they have said that it should be avoided in hospital use. So WHO is now saying that they do not have sufficient evidence that hydroxychloroquine helps patients in surviving in hospitals, not patients who are in home isolation. Nothing said about that. But based on these recommendation, many countries have taken off hydroxychloroquine from their national guidelines. So this is our observation with hydroxychloroquine in Bangladesh. We don't say that hydroxychloroquine is a wonder drug, it's an antiviral. Actually, I have said that even I personally don't believe in hydroxychloroquine. But in 2 observational studies from Bangladesh, from 2 tertiary level hospitals, we have seen that hydroxychloroquine treated patients do recover. So again, the question comes whether, you see, it is the antiviral that is playing the trick or not. But at least these 2 articles recently published from our group has established the safety of hydroxychloroquine in a small number of patients. And the largest experience is the experience in the Indian subcontinent, where the drug has been used for many decades now for treatment of malaria. So I was wondering, I always wonder, why hydroxychloroquine? If remdesivir can be a drug, if favipiravir can be a drug, so why not hydroxychloroquine? Then I thought that I'll go back to the history. And when I go back to the history, very interesting things come up to my mind. One is the sword of Tipu Sultan, other is Acharya Prafulla Chandra Ray. We all know of Tipu Sultan in 1799, when Tipu's Srirangapatna fell to the British had a huge celebration because they had conquered the south of India. But the celebration was very short-lived because malaria struck, and the British immediately shifted their cantonment to Bengaluru. But again, there was also malaria. So there was research going on at that time, and quinine was developed. So perhaps the first clinical trial of a drug in modern times began in India with quinine, which showed mixed results. People were benefiting with quinine, but again, people are also getting infected. And then the British discovered that quinine has a bitter taste. So lack of compliance was an issue. Then further research went on, and quinine was mixed to juniper-based liquor. And then we had the gin and tonic. The gin and tonic, when you add juniper to quinine, it became sweet. And that is how eventually Bengaluru became the pub capital of India. Now, where does this Bengali person, Acharya Prafulla Chandra Ray, come in? This gentleman, Acharya Prafulla Chandra Ray, was born in the southern part of today's Bangladesh on the Bengal province of then undivided India. He was a PhD from Edinburgh University, but he was a strict nationalist, and he founded the first pharmaceutical industry in the Indian subcontinent in today's Bangladesh, which was subsequently relocated to West Bengal. And he founded it to fight as part of the Quit India movement, so that India could be self-reliant of its medicines and don't have to depend on British anymore. So hydroxychloroquine is a product of Acharya Prafulla Chandra Ray's Bengal chemicals. And today India produces 70% hydroxychloroquine produced in the world, and Bengal Chemical is still the largest producer of hydroxychloroquine in the world. So I always wondered that had hydroxychloroquine been developed by Gilead or some other Western major pharmaceutical industry, maybe hydroxychloroquine would not have been targeted, or maybe it would have had, maybe, I don't know, emergency use approval like remdesivir has without significant survival benefit. Now let's go to the vaccine story. We also are now listening to vaccines coming up, and we have our neighbor China coming up with vaccines. In fact, they are also approaching Bangladesh to have a clinical trial of a vaccine. Now, when I go to the Chinese vaccine history, that I see that they have so far developed only 2 vaccines. One is the hepatitis E vaccine, and you can see that this vaccine is not marketed anywhere in the world outside China. And when I go to the dengue vaccine, I see that, yes, they have also developed a vaccine, but even they have not been able to market it inside China. It is in the development phase. So with 2 vaccine development in the long history of vaccine research, one is not yet in Chinese market, other has not gone beyond Chinese market. So coming to this part of the slides or my talk, this cartoon, attracts me much. I don't want to go into details, but what attracts me is that up to now, we know very little about this virus. We only know certain aspects of what it does. And we are actually practicing socio-political remedies that are actually not purely scientific, rather they are quasi-scientific. And actually what we see around us is largely a political freestyle wrestling. Whoever has the might can, struck off hydroxychloroquine from your prescription list, can introduce remdesivir, can show you hope with tocilizumab without any concrete evidence, can tell you that a vaccine is coming from China and things like that. So this is why I say that COVID-19 is not only a physician's plea, and is not a disease only. It has socio-political aspects. The challenges are there, and the challenges vary from regions. So now, where do we stand in India and Bangladesh in facing COVID-19? There is our stand. We have a huge Rohingya refugee concentration in Bangladesh, more than 1 million living in a small area. It is me and my team, when we have had several study projects in the Rohingya camps. We have seen that they have the largest hepatitis C virus prevalence in the world, which is a very dangerous thing to happen, the time bomb like situation. And you see, despite our remarkable development, these type of slums are still there in today's Mumbai or today's Dhaka. So it is not unlikely that we are now facing a serious challenge of COVID. Mere angene mein COVID is not yet controlled. You see the Bangladesh and India side by side. Total cases daily, total cases are still on the rise. Total deaths are on the rise, and we don't see the arrogant COVID curve flattening yet. In both our countries, we are possibly seeing a plateau curve of COVID. But interestingly, you see, on 13 July in Bangladesh, 73% plus dedicated COVID hospital beds are empty. 50% plus dedicated COVID ICUs are empty. Despite patient number increasing, the fact remains that our hospitals are empty. Our ICU beds are empty. So what is happening? So this is a recent newspaper article that I wrote, that what is happening in Bangladesh. And I understand the same is happening in certain parts of India also. I think the explanation is that we are fortunate to have it late. Had the virus come to Bangladesh or India from China and not via Europe, we would have had hundreds and thousands of people dead by now. Since we got 2-3 months time, we could prepare more, understand the disease pathogenesis more. And so we are better equipped to treat the disease. And then adaptation to telemedicine. Our people are highly adaptive. Now in Bangladesh, when someone gets infected, instead of running to a hospital, he looks for a physician, and the doctor advises him, and they get cured by home isolation. In my case, I got infected, my wife got infected, and my son got infected.
Excuse me,
what
Dr.
we
Mehta.
did was, I had my lungs infected, involved also.
Dr. Mehta, you have 2 minutes only.
Okay. So what I'm saying is that, yes, so we managed it like this. We have adopted to telemedicine, like hepatologists providing telemedicine support. We have used telemedicine to revive our endoscopy, and this is a innovative thing. How we prevent the spread of the aerosol spread during our endoscopies. That's why I see the mother of invention, and we are seeing the benefits of telemedicine number of ways, and we have published all these data. So now what we have taken the concentration camp versus the box the vulnerable approach. Means previously all COVID patients were hospitalized. Now we only hospitalize the patients who have comorbidities, who are at risk, and the rest can be treated at home. I won't go into NASVAC. This is a new drug that we are working on. It has the therapeutic potential, and we are working on it, but not the time here to discuss any further. What I want to say at the end is, if we want to combat COVID, we have to emphasize on regional collaboration. And in case of India and Bangladesh, we have a long-standing, firm history of collaboration. This is the Bangladeshi concentration camp of Bangladeshi refugees. 10 million of us went there and stayed in 9 months in India during our war of liberation. Here you see the Pakistan army surrender into the Bangladeshis in Dhaka, and the historic relationship that we had since Mujib Indir and today between Modi and Sheikh Hasina. So, and this is the example of Indian support to Bangladesh during the COVID-19 pandemic. Indian aid that came to Bangladesh initially. So what I say is that we are now facing the third world situation, and in the post-third world era, in the new normal lifestyle, we don't have to rely on remdesivir and things like that only. We have our capability, we have our adaptability, and we too should collaborate strongly. And the next area of cooperation is possibly vaccine. Serum Institute India Limited has the largest producer of vaccines in the world. They have a contract with Oxford. This is my humble plea that we should concentrate in collaborating in vaccine and other areas between our two countries, and then how we can face this regional challenge. Because COVID is a global pandemic, but the pandemic changes its character from region to region, and this character is not guided by the virus itself, but a number of socio-political economic factors also guide it. So thank you very much.
Thank you, Dr. Mehta, for this wonderful talk. And many more things you illustrated, and we came to know about different aspects of the therapy that the clinicians are practicing on the patients. And you have also highlighted very nicely how to keep our life safe by social distancing and by taking precautions and following the guidelines by the government given time to time. So with these lines and
Chairman, sir.
social distance precautions and following the guidelines. Yeah. Is
Chairman,
okay?
sir.
I'm audible?
Yeah, Chairman, sir.
I'm audible? Yes. Yes.
Actually, I got the mail yesterday from Dr. M.P. Yadav. He's ex-Vice Chancellor Sardar Vallabh Bhai Patel University of Agriculture, Technology and Merit, and the Principal Scientist IVRI. He raised some points.
Yes.
Okay. That he's requested to be discussed. And the one question number one, the Professor Mamun is here, and Dr. Bhojraj sir are so I want to read the questions. What is community transmission? For any definition given for this by WHO, probably by and large people do not understand the meaning or definition of community transmission. Question number one. Question number two, recently there is a debate whether COVID-19 caused by SARS coronavirus 2 is airborne or not. So if any of them can answer, please, you can ask the question.
Dr. Mehta, would like to take this question?
Yeah, but let me give my perspective. There is a very difficult questions to answer. I think during my talk, although I had to rush, I tried to clarify the airborne thing. It is possibly airborne, but there is not enough evidence for that. Who has actually accepted that it is a airborne virus, and it possibly lasts in the air for certain minutes. So since it is still a matter of research, right now the approach should be, I think, it's my opinion, that wearing masks is very important, that we all know of, and we should try to avoid close contact and close spaces. Especially physicians, teachers teaching in classrooms, physicians doing endoscopies or surgeries, people praying in mosques or mandirs or temples or churches in closed rooms, that should be discouraged as much as possible. And what is social spread? My definition of social spread is when a person gets infected and the source person cannot be identified, that is social spread. When we doctors get infected, we perhaps know that yes, we got infected from that particular patient or from that gentleman who came to see me, or I went on a ward round. But now in India, Bangladesh, what we are happening is we are having asymptomatic patients. We don't know that we have the disease. We get tested for some reason, or we had fever, we had some ailments. We get tested and we become positive, and we don't know how we got infected because anyone around us may be infected. This is possibly my definition of social spread. Thank you.
Thank you so much, Dr. Mehta. And now these things are coming up gradually, and people are raising doubts about the presence of this SARS-CoV-2 in the air. But definitely there are not sufficient evidences to support it. So thank you so much. Now with this, I would request Professor Viru Prakash to please call the next speaker.
Yashodhara, madam.
Thank you, sir. Good afternoon, everyone. Our next speaker is Professor Abbas Ali Mehdi. Professor Abbas Ali, sir, is presently serving the Department of Biochemistry in the capacity of Professor and Head at King George's Medical University, Lucknow. He has been founder Vice Chancellor of Era University, Lucknow. Professor Mehndi has more than 35 years of research and teaching experience with over 375 publications with over 13,000 citations, including book chapters and books. He has supervised over 50 research projects, including the prestigious DST FIST and the World Academy of Science, Italy TWAS projects. He has delivered over 100 invited talks at international, national scientific institutions and conferences. His area of research includes free radical biology, natural products, nutraceuticals, and metal toxicity. Professor Mehndi has received several awards for his outstanding academic research and administrative contributions, including the Fellowship of National Academy of Medical Sciences in India. He is an editor, member of editorial board of international and national journals, and is a reviewer of innumerable national and international journals of repute. He has been president of 3 national bodies, including Association of Clinical Biochemists of India, Indian Academy of Biomedical Sciences, and Indian Society for Lead Awareness and Research. I now hand over the session to the chairman.
Thank you. Yeah, thank you, Dr. Yashudra, for introducing the learned speaker. Professor Abbas Mahdi knows no introduction, in fact. He is very popular in India and abroad. And overall, he is a very good human being, very hardworking scientist. So we welcome Professor Mahdi to please take on.
Thank you, Chairperson. It's a pleasure and honor for me to be participating in this webinar and to be invited by Sushmaji. I'll be talking, my job has been made easier by the previous speaker who has given a wonderful talk about this pandemic. No doubt this pandemic has changed the whole world, and I'll be speaking, basically I'm not a virologist, I'm not a person of from virus research, but my only association has been in 5-6 months when our institution and the state government and ICMR gave me the responsibility to maintain the chain of supply and to expand the testing facilities. So I'll talk about, I'll skip the initial slides regarding the coronavirus, its origin and how it started from Wuhan in December 2019, and that's how it is named as COVID-19. So and why it is called corona and all that we have been hearing yesterday. So I'm skipping these slides regarding the origin and all that. Now, as far as the current situation in India is concerned, we are having the 6 cities in India where the maximum concentration of more than 11 lakh patients which are reported in last few months in India. They are basically concentrated in Mumbai, Delhi, Ahmedabad, Chennai, Pune, and Calcutta. And among the state of Uttar Pradesh, it's Tamil Nadu, Delhi, Karnataka, Andhra, starting with Maharashtra, which is having the maximum number of cases, which is 3 lakhs plus as of yesterday. So, and Lakshadweep is the only region in India which, as of 13th of July, doesn't reported any case in India. But rest, all over India, we are getting cases, and a lot many cases are there, even in our city of Lucknow also. Now, the story and the timeline in India started from 30th of January, and we in Lucknow also started around that time preparing ourselves for the diagnosis and for the treatment modalities, devising treatment modalities. And this is the timeline. I'm skipping it because we all know that how there was a initial Janta curfew on 22nd of March, followed by the national lockdown, which continued till initially till 14th of April, and then it continued and till 30th of May. And now there is lockdowns which are no doubt helping a bit in the containment of the disease. But as such, we are seeing lot number of cases. Now, as far as India is concerned, here lot many scientific organizations have been there, but Indian Council of Medical Research, that is ICMR, is the apex body in India, which is basically responsible for promotion and coordination of biomedical research, and it is one of the oldest medical research bodies in the world. And it promotes basically the biomedical research in the country. And it took up the responsibility and the challenge initially, and it formed various teams, with the nerve center being the National Institute of Virology at Pune. And not many teams were formed for lab work, networking, diagnostic kit procurement and evaluation. Moreover, lot many committees were formed by the Indian Council of Medical Research, and National Institute of Virology of ICMR at Pune functions at the resource center for the VDRL network, which is in India. And we are having initially we were having about 157 virus research and diagnostic laboratories across India. And now it is being expanding. And as of yesterday, that is 20th of July, in India, we are having in the government setup about 892 labs, which are basically in the government sector, and 382 total, 1,274 labs, which are basically responsible for having the real-time PCR and TrueNet and CBNet facilities for the testing. And this is how it is, lab networking is spread over all over India. And day by day, it is being expanded. And that is the reason why up till now, we have done more than 1 crore tests. And yesterday, it was one of the maximum number of tests which were conducted in India as per Indian Council of Medical Research. That is over 333,395 tests were conducted yesterday. And Uttar Pradesh contributed a lot in it, because around 40,000 plus tests we did in Uttar Pradesh. Now, diagnostic kits are being provided by the Indian Council of Medical Research across India, and its validation and evaluation is also being done by ICMR, and lot many centers have been established for the validation. Initially, only NIV Pune was doing it. Now, even our institution, that is King George Medical University, Department of Microbiology, is also evaluating the kits, and there is fast track approval of the kits and supply of the kits and reagents to all government labs throughout the country through 14 regional ICMR depots. One of the depot we are having for Uttar Pradesh in our institution. Unfortunately, I'm looking after it. So we are catering to the needs of the labs across the Uttar Pradesh. Now, procurement is done centrally, and then distribution is carried out, and a team is responsible for distributing it across the country. And these are depots, regional depots are there in the north, south, east, west, and that is how it is being maintained. And there is a national task force which oversees all this continuously. It monitors, and this is the apex body in India under the
इसमें हमारे में तो आ नहीं रहा है, हमारे में तो
then we have got the research group.
कहाँ है ये क्वेश्चन बॉक्स?
डॉक्टर शर्मा, आप अपना मोबाइल वो आप अपना जो स्क्रीन है वो म्यूट कर लीजिए. डॉक्टर शर्मा, म्यूट कर लो आप. डॉक्टर शर्मा,
हाँ, अच्छा ठीक है, ओके ओके.
So, Dr. Sharma, mute कर लिया. Now there is multicentric therapeutic research also, like for example, plasma therapy, BCG, hydroxychloroquine, and the WHO solicited trials are being conducted under the aegis of this Indian Council of Medical Research. Even there is a policy group for Ayush, that is on Ayurveda, Unani, homeopathy, and other alternative systems of medicine, which is centrally located at Indian Council of Medical Research, and continuously data analysis and collection and analysis is being done at the central level. It is being managed by the teams, various teams, and ICMR has come up with guidelines, national guidelines, for example, for the ethics committee, for going through the various projects and clinical trials which are coming up. So national guidelines have been made. Similarly, guidelines for the management of pregnant women, guidelines for testing, similarly, even guidelines for autopsy and for the disposal of the dead bodies has been made by Indian Council of Medical Research. So Indian Council of Medical Research in last few months have come up very boldly in catering to the needs of this pandemic, and they have done tremendous job in last few weeks and few months in spreading the awareness, in spreading the testing facilities across the country, and they are encouraging now day by day. They are emphasizing that all the government and private medical colleges across the India, which are more than 500 at the moment, they should also start with the testing. And in Uttar Pradesh, we are shortly going to have, by the end of July, we are going to have 10, 15 more centers. In Uttar Pradesh, we are having at least, I think, around 150 centers where the testing facilities are available, and continuously the efforts are being made to increase it more and more, so that about 1 lakh tests are done in UP alone. And India also, there is expansion, lot much expansion. So symptoms I'm just skipping, because mild, moderate, and extreme symptoms we have been talking about, and the risk factors which are associated, that is aged people are more prone to the COVID-19. Similarly, the persons who are suffering from non-communicable diseases like hypertension, diabetes, cardiac diseases. We have heard a very wonderful talk just prior to my talk. And the testing facilities which are available are serological testing and antigen testing, which is the rapid test. But the gold standard remains the reverse, this RT-PCR, that is the real-time PCR, which is the gold standard for the detection of the COVID. Now, as far as the treatment modalities are concerned, no doubt we have heard a lot just now about hydroxychloroquine and antiviral drugs which are available, or the steroids which are being used, or passive antibodies which are being used for the selected blockade of the cytokine cascade. But and of course, the role of NSAIDs and the corticosteroids, which is still controversial. But WHO has emphasized that the traditional and complementary and alternative medicines may benefit. And here I'll like to say a few words before going into my talk further, that we humans and Indians in particular, humans in general and Indians in particular, we just are extremists. We either fear from the thing and we go into the shell, or we think that we have won over the thing and we don't fear for anything. That is the major problem. या तो हम डर जाते हैं, और या फिर हम क्या कहते हैं, बिल्कुल शेर बन जाते हैं. So there is no balance amongst us. That is the major problem. And as far as the availability of medicines are concerned, or traditional medicines are concerned, lot much talk is there about the use of alternate medicine, and I'm hearing a lot about the use of turmeric added milk. But anything and everything which is taken in excess is not good. So my message to all of you is that anything and everything which is taken in balance, that may help you. Because for our immunity, we require basically for nutritive needs, we require carbohydrates, proteins, fats, vitamins, and minerals. So a balance has to be maintained. Carbohydrates are important for energy. Proteins are the building block. We all, those from the biochemistry, they know all. Similarly, fats are required. They are the building block, as well as they are the reservoir of the energy. Vitamins are required, minerals are required. They are helping in the augmenting into the functioning of the proteins. But a balance has to be maintained. If there is deficiency, then it should be supplemented. But if you take it unnecessarily, then there is a problem. Carbohydrates taken in excess is a problem. Proteins taken in excess is a problem. Fats taken in excess is a problem. Even vitamins, like for example, earlier people used to say that water-soluble vitamin like vitamin C, and these days for COVID, not many recommendations are there. Vitamin C, no doubt, is a immunomodulator. It boosts up our immunity, and it is vital and important for being the antioxidant, and it has got a large number of other roles also. But vitamin C not only is an antioxidant, but it is also a pro-oxidant. Dr. Bichan Sharma will agree with me that vitamin C in excess may lead to keeping iron in reduced state, and that may lead to more generation of free radicals. So a proper balance has to be maintained. But deficiencies of essential nutrients is quite common in countries like ours. So supplementation, especially in times like today's, when we are facing, somebody has unmuted the mic. Somebody has unmuted the mic. Huh. So in this, when the pandemic is there, or you see that all the time we have to face, there's a survival of the fittest. Yesterday, Dr. Bhojraj Singh has very nicely presented the things in a very clear manner, that there has to be a survival of the fittest, that if you are not well equipped to fight with the diseases, if you are not nutritionally well equipped, then you are going to succumb to diseases. So a balance has to be maintained. This I wanted to emphasize. Now, no doubt about it that zinc, selenium, iron, copper, manganese, magnesium, and vitamin A, vitamin E, and vitamin C are important in modulating our immune defense system. So they are needed continuously. They have to be supplemented in our diet, and the only source is the diet and nutrition, because these are the essential nutrients which have to be supplemented daily in our diet. Now, I'm skipping these, that role of macronutrients, that is carbohydrate, you know that they are the main source of energy, and proteins, again, they are required for being the building blocks, and they are needed being the component of most of the works which are done in the cell is carried out by the proteins. So that is why protein intake is very important and vital, and supply of essential amino acids in the diet has to be taken into consideration. So a variety of things should be taken, whether we are the vegetarians or non-vegetarians. We must continue to have a good supply of proteins in our diet, so that we are well versed with our immune defense machinery. Fats again play a very important and vital role. Yesterday, a very nice talk was given by Dr. Arora regarding the fats, and fats do play a role in modulating the immune defense system. So, but again, excess of anything is harmful. Similarly, excess of fats is harmful. The daily requirement of essential and non-essential fatty acids is vital. They are needed for the maintenance of the cells, for the maintenance of the body. But if they are in excess, whether they are the saturated fats or unsaturated fats, they become toxic. Similarly, the role of vitamin A plays a very important and significant role in modulating our immune defense machinery. And earlier it was said to be mainly involved in the our visual cycle, but its immunomodulatory role is well versed now, and proper supply of vitamin A in our diet has to be maintained. Similarly, B complex group of vitamins, they play a very important and vital role. Vitamin C, as I said, that about 40 milligram of vitamin C we require daily, on that is the recommended daily dose of vitamin C. But even if we are taking the saline tablet, which comes for 500 milligram, that is sufficient to cater to our needs, and there is no need to go in for 1 gram or 4 gram, as has been said in last few months in a number of studies. I don't recommend that. Vitamin C is vital, important, being an antioxidant. It maintains lot many functions in our body, not only for scurvy, for which it was involved, for the gums and teeth, it was said to be involved. It is involved in lot many other things. It is a very essential substance, and it has got antiviral properties. So a proper supply of vitamin C, more so in its natural source, like for example, not many reports are coming in that lemons and oranges, they are a good source of supply of vitamin C. So in the natural form, you must consume on daily basis these things, like lemon tea you can consume, that is lukewarm water with the added lemon in it, that should be taken on daily basis. That can help you and facilitate you in maintaining your immune defense system. Vitamin D, again, is not only important for maintaining the calcium homeostasis or phosphorus homeostasis, it is also of late has come up in lot many roles, and vitamin C enhances our immune defense machinery. So, and world over, deficiency or insufficiency of vitamin C is well established. So we must take supplementation of vitamin D wherever there is a need, And need-based supplementation is required. Don't go in for excess, but go in for its assessment. If you are having deficiency or insufficiency, then supplementation maximum from the natural sources. But if it is less, then you can go in for the supplementation with the very dispensations which comes in the market. And vitamin D is said to play a very important role, being a potential adjuvant in treating patients with respiratory viral infections, because not many reports are coming up in literature that vitamin C helps and facilitates in quick recovery and following any infection, and also in viral infections also. So there are not many reports that how vitamin C helps and facilitates our immune defense machinery by helping and augmenting our T cells and dendritic cells, and also increasing the natural killer cells in killing up the pathogens and including the viruses. Now, as far as the minerals are concerned, zinc is very important and vital. More than 200 enzymes are there where zinc is a cofactor, and zinc deficiency plays a role in weakened immunity. And you must have been hearing a lot that if zinc deficiency is there in the children, then they are prone to repeated diarrhea. Our previous speaker was from Bangladesh, and the study came in association of India and Bangladesh that the zinc supplementation prevents diarrhea in children, and that is why it is recommended now. So zinc play a very important role in maintaining our immune functioning, and it's the gatekeeper of immune defense system. So a balance has to be maintained. But remember here also that excess of even zinc is harmful, is determinant. So anything in excess, as I said, is harmful. Similarly, zinc has to be maintained, and not many foods, natural foods are there, cereals, wheat germ, and pumpkin seeds, meat, then fruits are there, nuts are there, which are rich source of zinc, and you must consume all these. A variety has to be there in our diet. As it is said that add color to your diet, which is very beneficial in a long run. So zinc supplementation is important and vital, especially in those who are having its deficiency. And we Indians are said to be having low zinc also. So diets which are good source of zinc supplementation should be taken. And if there is less zinc in our system, then of course supplementation can be taken, and the tablets which are coming, which are having zinc in it, they can be taken and consumed, of course on a physician's advice. I'll advise it. So how zinc help and facilitates in interfering with the viral replication cycle is depicted in this, and zinc interferes with the virus replication, and that's how it is helpful and beneficial in eliminating the viral infection. And not only that, it is also important in enhancing our immunity, maintenance of fertility. Also, it was said to be there that zinc deficiency causes infertility, but zinc is very vital and important for maintaining our immune homeostasis. So that is why zinc supplementation has to be there in the diet. Another element is selenium, and selenium, lot many work has been done in dengue, but of late in viral infections also, not many selenoproteins deficiency is said to play a role in the disease. Not much reports I have seen as yet on the selenium deficiency and this COVID, but in dengue virus, I have seen a lot many reports that in those who are having insufficiency with selenium, then the outcome is poor. So zinc plays a very important role. It's the mineral which is important and vital for immune health, and selenium supplements may enhance antiviral defense against influenza strains, that is including H1N1 that has been there in animal studies. So selenium is another, and radish and not many vegetables, they are good source of selenium. So they should be taken in our diet, and that can supplement our needs for this essential element. Now, as far as phytochemicals are concerned, not much work is being carried out in India of late regarding the role of phytochemicals as drug. And we have got the Ayurveda, Unani, and Siddha systems where phytochemicals were used. And I'm skipping this. No, as far as we are concerned, I'm concentrating mainly on the studies which we conducted, of course, not on COVID, but other diseases in which medicinal plants having possible treatment modalities for COVID-19, and they should be tested, and they are being tested, like Tinosporia cardifolia, Methania somnifera, that is ashwagandha, Ocim sanctum, Nigella sativa, ginger, Artemisia, metha, and then this honey, and long, and ajwain, the common names of these two, clove and ajwain. I don't remember what is the name of for ajwain in English, but they are being used a lot these days for preventing COVID. So as far as Tinosporia cordifolia is concerned, Guduchi, as it is called in or Giloi, it is called in the local language, is the plant which is said to have immunomodulatory activity. I'm coming up. I'm coming, just finishing. 2 minutes.
Yes.
1 minute.
2 minutes.
1 minute. 1 minute. 1 minute.
Okay.
This Tinospora cardifolia, we have published a few reports, and it has been shown to work in cancer cell lines. It has got pro-apoptotic role, and so it is being used in COVID also. Similarly, ashwagandha, lot many reports are there. This is Methania somnifera. They're withenoids. They are said to having antiviral activities, and they are immunomodulators. So they help and facilitate in modulating our immune defense system. We have published a few papers about Methania, of course not an antiviral or immune improvement, but general well-being we have published. Similarly, ginger, we have published some anti-cancer and antioxidant activity of ginger a few years back. So what I say, or what I conclude in the end, that all these things which are the so-called local supplements which are available, don't go in for, none is going to give you immortality. They are there to help and facilitate in helping and facilitating those who are having immunocompromised status, or those who are having deficiencies or insufficiencies. So go for a balanced diet, take everything, don't take anything in excess, because excess of anything is harmful. I always say and tell my students that even the excess of oxygen is harmful. So if you take more oxygen, it is harmful. Water is harmful. Without oxygen, we cannot survive. But only on oxygen also we cannot survive. So oxygen can be toxic. Similarly, carbon monoxide is a toxicant, but carbon monoxide we produce, it is a immunomodulator, it is a neuromodulator. So it has got a beneficial role also. So everything which is harmful may have a positive role, or everything which is useful also have got negative roles. So a balance has to be maintained in everything, and a balanced diet and proper nutrition is vital and important, not only in maintaining your health, but also in fighting with the diseases. That is what my message is. Thank you. Thank you very much.
Yeah, thank you, Professor Madhi, for this wonderful talk. You started from the national scenario of combating COVID-19 at present times in India, and you presented lot many things, the government efforts being made for the safety of the people and their treatment also against the disease. And the part that you highlighted about the natural therapeutics, that was really wonderful, because I was looking for, there were several synthetic drugs, like Dr. Mehtab told about the remdesivir and anti-HIV drugs and hydroxychloroquine and all that. But despite the fact the natural compounds that you were talking about and you have projected in your slides, there is no substitute to it, because they are safe, they are non-toxic, and they are very, very efficacious. So that was one thing. And another is about the micronutrients you highlighted. Really is, I think, a very good area to explore in context of the COVID-19, as how to use them for the boosting immunity, as well as to make the health of the patient in order, in a very balanced situation. I agree with you that anything excess is really toxic to the health of the person. And that's why once we go for describing the definition of poison, the poison defines anything which is in excess. Actually, with the very clean water can be a poison if taken in excess. So that have very good talk, and we all got benefited out of it. So with this, I thank you once again for this very illustrious and informative talk. And I would like to take up a couple of questions asked by some of the audience. One is Dr. Sheikh Shahnaz, and he asked about the um, utility of taking this chicken soup along with the vitamins and zinc for the COVID-19 patients. So there is some controversy and some kind of, the rumor that one should not take the chicken soup. So what is your opinion about it?
I think chicken soup will contain most of the well, essential nutrients. Am I audible? Am I
Yes, sir.
audible?
Yes.
Yes, sir. Yes, sir.
So I think chicken soup will contain all the essential nutrients. So I don't think there is any harm in it. But again, whatever you are consuming, consume in a proper proportion. That is very vital and important. Now, as far as soup is concerned, don't supplement it with additional nutrients like zinc or anything else, because it is already having all the ingredients. Meat has got all the ingredients. So whatever you are consuming, you consume in the natural form. That will help and facilitate in augmenting your immune defense system. That is what my message is.
Okay, thank you so much because we are lagging behind the time. Uh, if from the audience someone wants to ask a question directly, just one question. Okay, if no question, once again, thank you so much, Professor Mahdi, for being with us and sharing your knowledge and publication and all those research things for the utility of the research scholars and for the utility of the wider audience as such. Thank you so much. So with this, I would request Professor Dr. Yashodraji to call the next speaker.
I take privilege to introduce Dr. Kin Maung Win, sir. Dr. Kin Maung Win is serving as head of the Department of Hepatology in Yangon. He is graduated from Myanmar University of Medicine and obtained master's degree in internal medicine. He is trained in gastrointestinal and liver services in Royal Infirmary, Edinburgh. He has also served the liver unit of Royal Free Hospital, London, as an assistant lecturer and has served in the liver unit, Yangon General Hospital in liver unit, as well as professor and head of the Department of External Medicines and Department of Medical Research, Department of Hepatology, Yangon. Sir has achieved magnetic resonance cholangiopancreatography, as well as Fellow of Royal Challenges Physician, Fellow of American Association for Study of Liver Diseases. He is also recipient of WHO Fellowship in 1991 and worked at Hôpital Henri Mondor, Paris. Sir is well trained in clinical hepatology and his team works on effect of TGB beta on hepatic stellate cells. He has established Yangon Gastrointestinal Liver Center where he serves as head department of hepatology till date. He was awarded as honorary professor, Department of Hepatology, University of Medicine, and by Ministry of Health and Sports, Myanmar. Over to Chairman, sir.
Thank you, Dr. Yashodhara, for presenting the introduction of Professor Kim Bong Wen from Myanmar. Welcome, Professor Kim, and I hope you are listening me. So I would like to call you to please start your talk. Professor Kim.
Thank you very much, organizers, for inviting me, and thank you for your kind introduction. The topic I was assigned was COVID-19 and fatty liver. I think you all can hear me very well. Can you hear me well?
Yes,
Yes,
sir, you're
sure,
audible.
sure.
Yes.
Okay. COVID-19 is become a serious threat to the whole world and a public problem. It is caused by the SARS-CoV-2 virus. It is related to the severe acute respiratory syndrome, SARS and the MERS, and all these viral infections can lead to fatal acute respiratory syndrome in human beings. I would like to repeat, the disease is COVID-19 and the virus is SARS-CoV-2 virus. Allow me to tell the story of the evolution of the COVID-19 during the last 6 or 7 months. It started from the Wuhan, China. It was reported in December 30th, 2019, a cluster of pneumonia cases. On the January 17th, the coronavirus was isolated. And January 11th, first fatality case was reported. And in January 12, 2020, it was named 2019 coronavirus. The genome made publicly available. And on January 13, the first reported case outside of China from Thailand. In January 20th, 2020, first case reported in US, a traveler from Wuhan. In January 30th, WHO declares global health emergency. WHO was still very reluctant to announce it as a global pandemic. That is the reason the United States was very angry, because you do not announce a pandemic, US cannot stop the flights from China. The Americans blame because of you. And WHO names the disease as COVID-19 on February 11th. Only on the February 26th, CDC confirms first possible instance, and only on March 11, 2020, WHO declares COVID-19 as global pandemic. This is the virus. These are the very small viruses, SARS-CoV, MERS-CoV, and SARS-CoV-2. The viruses were thought to infect only animals until the world witnessed acute respiratory SARS outbreak caused by SARS-CoV in 2002. The virus, we all now are very familiar, nucleocapsid and the envelope protein and the spikes contain S protein and the glycoprotein, membrane protein. Amongst all, this spikes protein is very important. It has the external domain of that can bind with the external domain of the receptor, ACE2 receptor. To tell you about the beginning, this SARS-CoV-2 is very similar. Very similar to the coronaviruses in the bats, and the bats intraspecies, then interspecies, then to the human being, leading to alpha coronavirus, lineage beta coronavirus. So in Wuhan, they really eat bats. Although it is named as Wuhan Seafood Market, all sorts of animals are available, wild animals, which the outside world, the people we never think about eating or having anything to do with this kind of viruses. This is the genome organization of the genomic organization of the beta coronaviruses, 5', the 3', ORF1, ORF1b, and this is phylogenetic tree computer generated. You see the beta coronaviruses are here, alpha coronaviruses are here, delta coronaviruses are here. So genomic variation SARS-CoV-2 is very similar to SARS-like viruses, 80% identical to the previous human coronaviruses, the spikes protein, envelope protein, membrane protein, nucleocapsid genes, the pathogenesis. These viruses are attached to each other very loosely with these spikes, and when they bind to the ACE2 receptor of the external membrane, extramembrane domain of the ACE2 receptor, the virus has a fusion, and the fusion, and then the virus get into the cells and uncoated, then replication, translation, from the Golgi apparatus, assembly, vesicle, and the viruses are released. In fact, I have to say that the viruses are not cytopathic. It is the most important factor in the pathogenesis is the host viruses, leading to cytokine storm and leading to production of the inflammatory processes everywhere. Most affected is the lungs, because lung has the highest number of the ACE2 receptors. So this systemic inflammatory response, SIRS, is due to the production of the GM-CSF, leading to activate the CD14, CD16, IL-6, that leads to cytokine storm, and that leads to widespread pathogenic effects in all the target organs, most particularly affecting the respiratory system, leading to death. Again, this cartoon shows you the SARS-CoV-2 virus affecting the GM-CSF, CD14, CD16, leading to monokines, inflammatory macrophages. I would like to remind you that the liver is the only organ in the body with the highest number of macrophages, leading to production of the chemokines and cytokines, leading to SIRS. So the conclusion and perspective for my introduction, zoonotic source of SARS-CoV-2 is not confirmed. However, it is presumed that bats as the key reservoir. And there was also accusations that Chinese scientists created the virus in the laboratory and spread to the outside world, which the Prime Minister of Australia and President Donald Trump demanded to the Chinese authorities to admit. Which the Chinese people flatly denied, no, nothing related to that. So at the moment, no treatment. However, remdesivir is approved by the US FDA. And the whole world now agree that there should be a complete ban on the utilizing wild animals, bats as a source of food. Besides the development of most efficient drug, it is a strategy to rapidly control the SARS-CoV-2 in suspected patients is also required. Therefore, accurate and rapid diagnostic kit or meter is entirely essential. PCR-based test is expensive and the time-consuming. In Myanmar, we can test only around 800 to 1,000 cases a day because it's too expensive. So with this, I would like to move on the next topic, NAFLD or comorbidities. That's the question. The implication of NAFLD on the clinical outcomes in patients with SARS-CoV-2 is very interesting. Around 37.6% prevalence of the non-alcoholic fatty disease, and the prevalence of NAFLD in China ranges from 15% to 47%. In the absence of histological data, obviously we cannot take the liver biopsy from the SARS-CoV-2 virus. We use hepatic steatosis index, HSI, for the diagnosis of the NAFLD. HSI is very simple. Hepatic steatosis index, HSI, means 8 into ALD-AST ratio plus BMI, plus 2 if type 2 diabetes, and plus 2 if female. If it is more than 36 points, it is diagnosed as a NAFLD. So SARS-CoV-2 infection is frequently associated with the increase in the transaminases and the gamma GT. Association between the NAFLD and the COVID-19 that will increase the risk of disease progression, longer viral shedding time, and indeed, the unfavorable clinical outcome of SARS-CoV-2 virus infection in frail patients is well known all over the world. So there was a study from the Chinese group where they confirmed COVID-19 patients with a NAFLD. Liver injury was defined as a ALD more than 30. NAFLD was identified by the HSI more than 36 points. And they have studied about 200 consecutive cases of the COVID-19. Liver injury was observed in 50% of the patients during the admission, and in the course of the hospitalization, it has increased to 75.2%. Almost all liver injury was mild with the hepatocellular pattern, 2.6%, and ductular or mixed pattern. Patients with NAFLD, a higher risk of disease progression, it is very, very, very significant. Abnormal liver functions from admission to discharge, longer viral shedding time. So NAFLD is definitely the risk factor for the disease progression in COVID-19 patients. So the part liver injury in COVID-19 patients is rather mild. Biliary cells, one very interesting thing is biliary cells have about 10 or 20 folds of ACE2 receptors than the liver, but high rate of spike protein in SARS-CoV-2, but there was very little ductular injury. Likely immune-mediated rather than being the result of direct cytopathic damage. That, I repeat again, it is not cytopathic. When the virus combines with the innate immune system, toll-like receptors combined with the viral element, that leads to downward signaling, that leads to stimulation of the NK cell, macrophages, T lymphocytes, CD90, series of immune modulations, immune stimulation. With increasing global prevalence of NAFLD, this may suggest that a proportion of our population could be at risk of a COVID-19 patient. In summary, underlying mechanisms for the severity of COVID-19 in NAFLD is unknown, but might be related to impairment of the immunity to the virus. There are also abundant ACE2 receptors in the small intestine and the biliary system and the liver. Liver contains the largest number of macrophages in the body and is a potent cytokine producer. Mind you, liver is a very potent cytokine producer. Impaired hepatic innate immune status might play a very significant role in the COVID-19 outcome. These are the references. You can obviously see the references are in the 2020, the journals immediately accept all the COVID-19 articles. Thank you very much. And with this, I will stop my presentation.
Thank you, Professor Wayne, for presenting very nice talk regarding the COVID-19. You started nicely from its historical perspective, and then on to its life cycle, how it invades, the lung cells, taking the help of AC2 receptors. And then after how the infection progresses, it synthesizes several structural and non-structural proteins, and then it comes out of the cell. The wonderful talk included one significant point which I could make it out was that the infection of this virus is not cytotoxic, unrelated to, unlike to other viruses, for example, HIV-1, which is really a virus which just tears the cell in pieces because it takes the cellular membrane as a covering of its own. But in this case, I find that the virus is very silently coming out of the cell. Second thing which comes to my mind, and I would like to know from you, whether there is association of any co-receptor, just like in case of the pathogenesis of HIV-1, where CXCR4 or CCR5 do exist. So in this case, there is no mention because several papers I have studied, and there is no mention of the co-receptor which facilitate the internalization of SARS-CoV-2 into the lung cells. So this is one question. And the other question from the audience has come from Dr. Anidita Viswas, that if the lung is the target of infection by SARS-CoV-2, why there is impact on the kidney cells. So would you please like to answer these two questions?
First of all, thank you very much for your kind comments and what's. The first question is to the co-receptors. Up to now, there is no confirmed, scientifically proven co-receptors. Regarding the second questions, the infection or the virus that can easily enter into the cell really depends upon the prevalence of the ACE2 receptors. So the lungs has the largest number of ACE2 receptors. However, the liver also ACE2 receptor. However, this does not clearly explain the simply the viral infection because the biliary system has the largest number of ACE2 receptors, 20 times more than the liver. And yet the biliary system does not have any clinical manifestations. So I presume the affinity of the virus to the cells really depends upon some unknown factors, but all the SARS, MERS, and the SARS-COVID-19, the viruses, all the viruses are particularly very prone to infect the respiratory system, and that can lead to fatal respiratory failure. Thank you very much.
Yeah, if you permit me, I can just ask next question. That is related to the synthesis of the proteins inside the cell. So in case of the HIV-1, there is a large polyprotein chain synthesized, and then the viral protease cleaves it into small pieces. Whereas in case of the SARS-CoV-2, what would you like to say? It is the polyprotein chain, or there are different mRNA synthesized from the positive strands of RNA of the genome of a SARS-CoV-2, so that the different sizes of the proteins could be synthesized?
We are in the very early phases of understanding the viral genome and the virus system, the synthesis. And at this point of time, the available references up to May, June 2020 does not clearly indicate these very subtle and very intricate mechanisms.
Okay, so there is one audience, Mr. Sheikh Sahnawaz, and he has raised the curiosity to know, is there any end to this virus in coming future?
In the very beginning of the outbreak, UK Prime Minister Boris Johnson said, don't worry, don't treat, let the whole general population 80 to 70% do be affected, and let the people have the herd immunity, and that will be the end of the viral infection. That was his proposition. Unfortunately, he was also infected, and now he's changed his mind. Dr. Fauci was regarded as President Donald Trump as his enemy, because Donald Trump is a believer in the end of this viral infection by the end of this year. Dr. Fauci said, no, this will persist till next year. So in the Tokyo Olympic, initially the organizers were very headstrong, and we won't defer, we will hold on the Olympic. Now they have postponed to next year. Now the Japanese scientists have said, no, we cannot allow the Olympic to be held in Japan if no effective vaccine is developed. So I must say, when this will end will be the $1 million question, and nobody knows.
That's very good to hear from you, Professor Wade. And
Chairman, sir.
Thank you so much. Yeah.
Chairman, sir.
Sure.
Sir, there is a query from the audience, and he says, to which extent plasma therapy is effective? So,
yeah,
the
question is
raised to the.
Yeah, Professor Wade, would you please answer?
Plasma therapy, I do not personally do not believe it will be very expensive, very complicated. In Myanmar also, we have trial with a limited number of patients. That is not practical to control the virus or to treat the virus for the whole general population, and also all the very ill and toxic patients. We need to have a very effective antiviral, for example, like a remdesivir. As soon as the virus goes up, you need to drop down the viral load very quickly. That will lead to the reduce the number of patients requiring the ICU therapy, requiring the respiratory therapy. So it is a very interesting, but it will not be practical to be in routine clinical practice.
Yeah, thank you so much. And more so, the concentration of the IgG, which should be there in the plasma of a corona recovered patient, and only then it will be some useful. But at the same time, there are several proteins from the host itself, which are being injected into the patient during this therapy. So that is the one part which should be taken care of. Otherwise, a lot of the side reactions and immunological complications may develop. So it has its own flip side also, along with the treatment point of view. So thank you so much, Professor Wade. And with this, I would request Dr. Yashodraji to please call the next speaker. Thank you so much.
Okay, sir. Thank you, sir. Our next speaker is Dr. Prashant Kumar. Dr. Prashant Kumar is serving Amity Institute of Virology and Immunology, Amity University, Noida, in the capacity of assistant professor. He has significant experience in the field of virology, medical virology, immunogen development, and nucleic acid-based therapeutic development. He has supervised and funded research projects on the generation of recombinant adeno virus, expressing therapeutic ribozymes and shRNA targeted to the genes of human metapneumovirus HMPV, which aimed at assessing the RAAV as prophylactic and therapeutic tool for inhibiting the replication of HMPV, Society of Microbiology, World Society of Virology, Indian Immunological Society, life member of Influenza Foundation of India. He has 22 research publications which are published both in national and international journals, and has attended several conferences, including invited lectures, and has also organized up to 4 workshops. He was also awarded the Young Scientist Award by Association of Clinical Biochemistry of India and International Travel Grant from DBT. Over to you, Chairman, sir.
So welcome, Dr. Prashant Kumar. Now, I would request you to kindly finish your talk in 15 minutes, and you can start it now. Dr. Prashant Kumar.
Am I audible now?
Sure, good.
Okay. Thank you, everyone. Good afternoon. First of all, I would like to thank the organizer for giving me this platform to speak. Since yesterday, we have seen several lectures and almost all the aspects of COVID-19 has already been covered. So whatever has been covered, I will simply run through those information. And to start with, I will. This has also been covered in today's lecture as well. We have seen during last 2 decades, several different human coronaviruses have shown their impact on human population. SARS-CoV and MERS-CoV, they have been more lethal as compared to SARS-CoV-2, but the cases that were reported in case of previous 2 viruses were quite less. In SARS-CoV-2, till yesterday, more than 14 million cases were reported with about 6.6 million deaths. So mortality rate is less, but the number of cases are quite high. So it's of great concern. The common thing among all these human coronaviruses is that their reservoirs of all the 3 are bat. And through one or the other intermediate host, they have entered into the human population. So bat is the main culprit in this case. Now, coming on to the classification, it has also been already discussed, and it has been discussed that of all the 4 genus, the coronavirus that had a good impact on human population belongs to the beta coronavirus. Now, this has also been discovered about the outbreak, how the outbreak of COVID-19 started, how it moved from bat to human beings through intermediate host. However, the intermediate host is still under question, whether pangolin is really responsible for transmitting the virus from bat to human beings. So it's being investigated, but it's not yet very much clear. Once it comes to human being, it transmits from one human to another human being very easily. And one question was there regarding community transmission. Here, I would like to say that if a person comes from an area which is COVID-19 infected, or if a person comes in contact with any infected individual and then gets infected, we can't call it as a community transmission. When we can call it as a community transmission if the source of infection is not well known. If the person has not traveled anywhere, if the person has not come in contact with any other infected individual, and then also he is found to be infected, then we can say that there is now a community transmission. So this is the case with the human population. So here, it is shown how the outbreak of COVID-19 turned into pandemic. A human population flying from one place to another place around the world can easily transmit. And the basic thing is that SARS-CoV-2 leads to asymptomatic infection as well. And being asymptomatic, a person if travels from one place to another place, he or she can easily travel because he can't be noticed for the infection. And this is how it has spread throughout the world. Symptomatic infection can easily be detected, and their transmission can easily be noticed. So this is how this outbreak turned into the pandemic. Now, coming on to the molecular insight of SARS-CoV-2, already it has also been discussed by so many speakers previously. Large number of scientists have already sequenced the genome of SARS-CoV-2. It is found to be 30 kb genome, positive sense single-stranded RNA genome. And being an RNA genome, it's very, very much prone to mutation. And we can say that a sequence of the genome that we are observing today may not be observed after 6 months or after 1 year. And this could be the reason that the virus that will be observed in future may be more virulent, it may be less virulent, we don't know. Actually, the nature only knows about it. So this 30 kb genome encodes for 29 ORFs, and of these 29 ORFs, only 4 of them encode for the structural protein, and rest all of them are either the non-structural proteins or the accessory proteins, which are expressed only in the infected host cell, and where they play their role in replication and multiplication of the virus. So it is also well discussed that who are at risk, almost every individual who doesn't take precaution, they are at risk, be it of any age. But individual above 60 years and below 10 years are more prone. We have seen, we have heard from our previous speakers that who all are more infected with the previously having, if they previously are having other complicated diseases. So now coming on to the symptoms, when an infected individual, when a person is infected, he or she may show multiple different types of symptoms, and which are very, very much confusing. Here we can see whatever symptoms are displayed over here, it can be observed in many other diseases like influenza, cold. So just based on the symptoms which a person is displaying, we can't say that the person is suffering from COVID-19. Out of all these symptoms, what we can see that only shortness of breath is exclusively observed in COVID-19, which is not observed in other related diseases like influenza and cold. So once the person starts displaying, one must go for a very specific diagnosis based on the various diagnostic procedures which are already in commercial use now. Now, once the symptoms are observed, we have seen who all are at risk. We have seen what are the symptoms. Now, how to manage COVID-19? Management of COVID-19 will involve, we must have a knowledge of how the virus is transmitted. So many previous speakers have already talked about it. If we know about it, we can block the transmission, we can limit the transmission, which is very, very much important for the control on pandemic. We should have a knowledge of the diagnostic systems. We should have a knowledge of a well-equipped healthcare systems where the symptomatic treatment along with the specific treatment may be provided. Apart from this, for research to manage this COVID-19, we should have a knowledge of viral characteristics, which will be very much helpful in the vaccine development like things. We should have a knowledge on replication of the virus, pathogenesis of the virus, which will help us in defining the therapeutic targets so that specific therapeutic strategies may be developed, which is not yet available anywhere. This is well talked about in our previous lectures, how it is transmitted. This was also discussed in our one of our yesterday's lecture, that when a person sneezes, a large number of water droplets are released of various sizes. The size of the water droplets actually range from 0.1 micron to 150 micron. And when a person sneezes, the water droplets can travel even up to 6 meters. And this makes it clear that why physical distancing is required, how physical distancing is important to prevent the transmission of this particular virus. Though the large droplets will settle down very easily within a matter of few seconds, but the smaller droplets, which like aerosols, which are less than 10 micron, they may remain hang up in air for minutes to hours. So even if you are not standing in front of an infected person, not talking to an infected person, then also it's very much possible that certain aerosols having viruses inside it may be roaming around in the air and you may inhale it. Here comes the role of mask. This shows why mask is important for all of us to prevent it. So by using mask and by maintaining the physical distancing, we can limit the transmission. And this is very, very much important apart from washing your hands repeatedly. So this is how we can have a control on the transmission. This replication procedures have already been discussed by our previous speakers, so I won't go into that much detail. I would only concentrate here when a virus infects a nasal epithelium, the virus multiplies inside the epithelial cells and the virus comes out. When the virus is released in our body, the immune cells come into play. They take up these viruses and they may show either a good immune response or a bad immune response. If there is a good immune response, obviously the memory B cells and memory T cells will be created over there for protection, and CTLs, antibodies, will be produced to get rid of this virus infection. But if there is a bad immune response, there can be so many, there can be a pathogenic things can be observed, which was very nicely described yesterday by one of our speaker, and it comes under immunopathogenesis. This again I won't discuss in detail because it has already been discussed very elaborately. So here we can see that the main role is there of the cytokine storm. Whenever the macrophage like things, lung macrophage like things take up the virus, it can release abnormal cytokines can be released in abnormal amount, and it can actually lead to edema in the lungs, hypoxia in the lungs, further leading to myocardial injury. Thereafter, lungs can also be affected, brain can also be affected. So almost all the many of the parts of our body is affected because of this. So this comes under immunopathogenesis. So it has also to be discussed about here. So this is again related to immunopathogenesis. The many of the immune cells release so many different cytokines, which may have very different effects in our different parts of our body. So coming on to the diagnosis. Diagnosis can be classified here in clinical diagnosis, laboratory diagnosis, and point of care diagnosis. So as discussed yesterday, if we talk about the clinical diagnosis, we can see a doctor can observe various signs and symptoms in the patient's body. Here we can see, I think none of the system of our body is left. Circulatory system, digestive system, excretory system, respiratory system, central nervous system, all the systems are almost affected by this COVID-19. So a doctor has to take care of all these symptoms and then correlate whether it is really a COVID-19 or not. Yesterday, very nicely it was discussed that X-ray images, CT scans can be very nicely used for differential diagnosis of this COVID-19, for differentiating it from other similar diseases. So a doctor has to take care of the signs and symptoms, radiologic images, etc. Coming on to the laboratory diagnosis. In case of the laboratory diagnosis, we go for the detection of virus in any patient's sample. So if we talk about the laboratory diagnosis, what we will detect in a virus? A virus has only these things which are displayed over here. It has a genome, it has surface protein, and nothing else is there in a virus particle. So we will detect either of these. So first, the gold standard diagnostic procedure that was initiated earlier was the nucleic acid amplification test, in which the viral genome was detected, and the tools that are used is real-time RT-PCR, and now genome sequencing is also being done. So for this, the sample that is taken from the patient is nasopharyngeal swab, which is expected to carry the viruses inside it. And from these nasopharyngeal swabs, total RNA is isolated, and from which several genes can be amplified. Now, which gene to amplify for the diagnostic test? Our previous speaker discussed that SARS-CoV-2 has about 80% similarity with another similar virus, SARS-CoV-1. So having 80% similarity is too much. So we will have to identify the unique regions that are present specifically in SARS-CoV-2, and those unique regions should be used for these type of tests for a specific diagnosis. So by multiple sequence alignment and various different procedures, unique conserved regions have been identified in the gene encoding spike protein, in the gene encoding RDRP, envelope protein, and nucleoprotein. And then these unique regions are amplified by real-time RT-PCR to go for the diagnosis. This is a very nice confirmatory test for COVID-19. The only demerit here is that it takes a long time and is very expensive. Using this technique in a resource-limited remote area may be very much difficult. So that's why other diagnostic techniques need to be looked for, which can be used in remote areas without any use of extra amount of money and all that. It should be cheap enough so that any person can go for it. It's very important. Other diagnostic techniques that are being used now are antibody-based immunoassay and antigen-based immunoassay as well. Both of them use ELISA. for this. So if you go for these two types of assay in the laboratory, here we use the, in case of antibody-based immunoassay, we go for the serum as a sample. The serum must be containing antibodies. Obviously, if you are talking about serum, we are going to detect the antibodies inside it. So these immunoassay detect either IgM or IgG antibody inside it. If allies that SARS-CoV-2 specific IgM is there in the serum, we can say that the person was infected 5 to 7 days before. And if ELISA shows that IgG antibody is there, we can say that the person was infected at least 2 weeks before. So this antibody-based immunoassay won't say about the current infection. They may not say about the current ongoing infection. This assay is generally used for surveillance purpose, and which is very, very much important from public health point of view. Coming on to antigen-based assay, this assay again uses ELISA, but here the sample is nasopharyngeal swab, where the virus can be present over there. So what is the diagnostic target here? The diagnostic target is either a spike protein or nucleocapsid protein of the virus. This assay will also tell us about the current ongoing infection with the help of ELISA, where the antibodies specific for the spike protein are used and they detect the spike protein of the virus. Now, what are point of care assay? We discussed about antibody-based immunoassay and antigen-based immunoassay. These two assay can also be done on the paper strip, just like the pregnancy kit. Certain strips are developed where, with the help of antibody-based immunoassay, we can go for detection of IgM or IgG by color change. And in case of antigen-based assay, we can go for checking the presence or absence of a spike protein by color change. So they are point of care test used for point of care testing. Sir? Yes, sir.
Dr. Prashantji, 2 minutes. 2 minutes, please.
Okay, sir. I will proceed, sir. So now coming on to the therapeutic targets. For developing the therapeutic strategies, we must know about the therapeutic targets. To know about the therapeutic targets, we must go in detail about the replications. So replication has already been discussed by our previous speakers. Here we can see the virus attaches to ACE2 receptor. The protease TMPRSS2 cleaves the spike protein into S1 and S2, when S2 now helps in the fusion of viral envelope with the cell membrane, so that the RNA genome is released over here. And this RNA genome is then translated to release produce early proteins of the virus, which include the replicase proteins. In the previous speaker talk, it was asked whether it is a polyprotein or not. Actually, it's a polyprotein. First of all, in the early translation, the polyprotein is synthesized, and then the protease is also synthesized, which cleaves this polyprotein to generate certain the replication complex, which is called replication transcription complex. If the protease won't be here, this polyprotein won't be cleaved, and this RTC won't be generated. This RTC converts this positive sense RNA genome into a negative sense RNA copy, which then acts as a template for the synthesis of multiple genomic RNA and for the messenger RNA, so that new viral protein can be synthesized. Now, how to determine the therapeutic target? Here, spike protein binds to ACE2. If we somehow block the spike protein, obviously it won't be able to bind to ACE2. How to block this spike protein? We can go for antibodies. We can go for we were talking about the convalescent serum. If a plasma serum is used, they may contain antibodies for the spike protein, and they will bind to the spike protein, won't allow the ACE2, won't allow the virus to bind to ACE2, and the infection will be stopped. Likewise, an inhibitor to TMPRSS2, which is already known, can also be used, which will prevent the cleavage of S protein into S1 and S2, and this will again stop the infection here. It won't allow the virus to release its RNA genome into the cytoplasm. Likewise, here, if we somehow block the proteases, so if the protease inhibitors are used here, the polyprotein won't be cleaved and RTC won't be generated. Ultimately, the viral particles won't be synthesized. So this is how we can determine the therapeutic targets. Here we can see in the bottom of the slide, hydroxychloroquine is also used. Hydroxychloroquine is actually it inhibits the endocytosis by increasing the pH of endosome. So if the pH of endosome will be increased, hydroxychloroquine, the virus won't be able to release the genome into the cytoplasm, and the infection will stop. Likewise, remdesivir actually blocks this RTC complex from synthesizing the negative sense RNA copy. And likewise, ribavirin is also another nucleoside inhibitor which can block this RTC complex. So these are some of the inhibitors which are being repurposed for use for against COVID-19. Likewise, apart from these therapeutic inhibitors, we have been talking about the cytokine storm in which IL-6, IL-1 beta were the main culprit. Nowadays, antibodies to IL-6, IL-1 beta are being used to reduce the effect of cytokine storm and to relieve the patients. So these are another therapeutic approaches which are being used for against COVID-19. Now coming on to the last thing, prophylactic strategies. Prophylactic strategies can involve vaccine development as well as use of immunomodulators. Our previous speaker, Dr. Abbas Ali Mahdi, very nicely discussed about the immunomodulators from the dietary sources. So I won't be discussing on this. I will be discussing a bit about the vaccine development. Whenever we talk about the vaccine, we talk to block the viruses from infecting ourselves. And whenever if there is an immune response, antibodies may be generated, which may block the spike protein here so that it is not infecting. Sir, I'm concluding, sir. Just
Dr. Prashant, please.
Sir,
Yeah.
yes, sir. Just I'm concluding, sir. So in vaccine development, we generally target the receptor binding domain of a spike protein. And these are some of the vaccine platforms here: DNA vaccine, RNA vaccine, a spike protein based vaccine, whole virus vaccine, which is attenuated or inactivated, like viral vector, either replicating recombinant viral vector, which will carry the spike protein gene inside it. Here, DNA vaccine and RNA vaccine, these also encode for the spike protein, which when delivered into the host body, they can produce a spike protein in the body, which can be recognized by the immune system and develop and produce antibodies against it and give other immune responses. So these are some of the vaccine platforms over here. Till date, more than 125 vaccine candidates have been developed by different scientific community. Most of them are spike protein based over here, followed by RNA, followed by viral vectors. These are some of the COVID-19 vaccines which are under clinical evaluations. Most important, most talked about are Moderna vaccine, which is mRNA vaccine, and Oxford vaccine. In India also, this is my last thing. In India also, 2 indigenous COVID-19 vaccine has been recently approved by CDSCO. They are Covaxin, which includes inactivated vaccine developed by Biotech, and JIBB, which is a plasmid DNA vaccine developed by Cadila. Both these vaccines are preparing to go for the clinical trial. But last but not the least, what is the fact? Fact is that MERS has been circulating, SARS-CoV-1 has been circulating. None of the vaccines have been developed since it has emerged. Do we really expect that we will get a vaccine in next 12 to 18 months? So we can just hope to get a good vaccine so that COVID-19 may be averted. So thank you so much. I will just say, don't panic, just take precautions. Thank you.
Thank you, Dr. Prashant Kumar, for presenting this nice talk. You started very well from its genesis to the prognosis part of it, diagnosis and the treatment aspects, and finally the slide that I was really very anxiously looking for was the therapeutic targets and the vaccines. So really the therapeutic targets that you have shown and some of the drugs which are really acting on some of the targets, but still we are really looking for some effective chemotherapeutic which can help block the proliferation of SARS-CoV-2 inside the lung cells. To me, you have talked several things about the diagnosis part and the vaccine also, that aspect you have covered. Now the question from the audience and from me also comes up is that, for example, in coming 1.5 years or 2 years, for example, if we have any indigenous or foreign vaccine against SARS-CoV-2, do you believe that it will impart complete protection from this virus?
Well, that's a very, very nice and important question. from research point of view, though we are trying to develop so many vaccines, but since it's an RNA virus, it's very much possible that the surface protein might show a significant change in it, which may not be recognized by the antibodies which will be developed by these vaccines. And this is the reason that most of the RNA viruses are not yet, a vaccine has not been generated against most of the RNA virus. So actually we can't say that the vaccines that are being developed today will be very much effective in the next year or next to next year. This is the fact actually. Yes.
That's true. And so the precautionary part that you have highlighted, that everyone is agreeing to it, that for the time being, the best thing to keep life safe is to follow the guidelines given by the government or the
Yes.
ICMR time to time. And since there is no specific therapeutic available, so only the precaution is the best cure, I hope.
Yes.
So
Yes.
with all these, I would like to take one or two questions if you have from the audience.
Yeah, I will welcome it. Yeah.
Okay, seems that everyone is satisfied because you explained it in so elaborative manner.
Sir, Chairman,
that
sir.
Yeah, sure. Please.
Chairman, sir. Please, sir.
Boliye.
Actually, there was a query yesterday from the one of the speakers, Dr. Udupa, and due to some problem, the question was not raised. So he is available. He is online. So can I ask the question on behalf of the audience?
Sure, please.
Yeah.
He quoted that I came to know through the electronic media that Glenmark has launched antiviral drug for treating COVID-19 patients. He first congratulated and asked about the efficacy of the drug and what is the actually recovery percentage of that. Can he answer, sir?
Dr. Prashant Kumar?
Well,
no. Venkatesh Udupa, sir. He is available.
I think the drug is released from Glenmark, so he will be the best person to answer.
Yeah. So Dr. Udupa? Dr. Udupa, can you hear us? Dr. Udupa?
Okay, may I know the name of that particular specific drug that is that has been released?
Yeah, that is a Flaviprovir.
Flavipiravir. Flavipiravir
that was actually launched by the Glenmark company.
Yeah, it was launched and it's being repurposed for use in COVID-19. I don't think that is highly specific for only SARS-CoV-2, but it has shown its efficacy. Yeah, it has shown its efficacy. But as per my knowledge, none of the drug is 100% foolproof to save all the patients. None of such studies has been done. But I would like to hear from Dr. Udupa if it can throw some light on it. Yeah.
Udupa sir is actually, he's online but not listening us. Okay, go ahead, sir.
I think it works something like remdesivir and ribavirin.
Yes, because they are specific drugs. Anyway, so thank you once again, Dr. Prashant Kumar, for presenting a very nice talk and informative talk for us. With this, I would...
Thank you so much, sir. Thank you so much.
I would request Dr. Yashodhara to kindly proceed.
Okay, sir. Thank you, sir. Our next speaker, in fact, the last speaker for today is Dr. Mansoor Ahmad Mir. Dr. Mansoor Ahmad Mir is serving as Coordinator, Head, Department of Bioresources, School of Biological Sciences, University of Kashmir. He has authored 12 international books with renowned repute international publishers, more than 50 book chapters to his credit, besides having more than 40 research papers in reputed peer-reviewed international journals. He is currently receiving royalty from Academic Press USA for his book entitled Developing Co-Stimulatory Molecules for Immunotherapy of Diseases. He is currently working on combinatorial therapies in triple-negative breast cancer. He is the member of the editorial board of some prestigious journals and has been an invited speaker at various scientific meetings, conferences within India and abroad. He is also a member of many scientific organizations and societies like International Immunology Association, Indian Association of Immunology, CHASCON, Indian National Science Association, Immunocon, etc. He has been MOOC course coordinator for immunology in 2018 and endocrinology in 2019 by the Academic Advisory Committee of CEC UGC. He was awarded Summer Research Fellowship by Indian National Science Academies for year 2019 and Teacher Associate for Research Excellence Award by the Science and Engineering Research Board Ministry of DST, Government of India in 2018. His basic research areas include tuberculosis, immunology, cancer, and stroke biology. Over to Chairman, sir.
Thank you, Dr. Yashudra, for giving the introduction of the speaker, Dr. Meir. I would request Dr. Meir to kindly proceed.
Am I audible?
Yes, yes, you are audible.
Okay, so good evening to all of you. Thank you so much for giving me an opportunity. I would like to thank all the organizers, especially the Professor B.R. Sharma sir and Professor Sushma ma'am, and the others who had taken this initiative in these tough and testing times to organize such a wonderful webinar where we had been given thought-provoking talks and the luminaries across the globe. So thank you so much for this. I had been listening to many of the talks which were very thought-provoking as far as the scientific community is concerned, and these webinars need to be conducted because we belong to different fields. We have been forced to live indoors because of the COVID-19 pandemic, and these type of webinars and these workshops are an important tool to keep us enthusiastic and to work for the solutions, whatever the challenges are there, especially the mankind is facing at present. My talk about this presentation, it was about vaccine candidates and the future challenge. As most of the topics had been covered and during various talks in the various aspects of the COVID-19, its genesis, how it spread, the diagnostics and the therapeutics, prophylactic measures, and various other aspects. The last one, I would like to talk about the vaccines, how vaccine candidates are going to help us in the near future, and various other aspects of it. So I would like to start my talk first that we have been provided with a robust and well-orchestrated immune system which continuously protects us from different challenges which are posed us from the environment, be it in the form of the bacteria and pathogens and fungi, or be in the form of the viruses. This is not the first time that the humankind has suffered such a massive setback in spite of having advancements in the science that we are suffering from a pandemic. Not only this, these had been in the past. There has been Spanish flu, there has been many plague, there has been many other pandemics which the humans have faced, and despite that, we had survived. So it means that the on which the predisposition we are facing, that our immune system is well enough or equipped to protect us from these pathogens, we are on the right track, that till despite many pandemics across the history, we are surviving and human race is still there. And with the Almighty's grace, we will face this pandemic and come out as successful race after this pandemic. As we have been talking about this COVID-19, I would like to begin first the genesis and the history of this, as most of the speakers had talked about it. But what is that the tragedy, not only that of the human sufferings in terms of the pathogenicity, but we are facing the socio-economic tragedy as well. There has not been as many as publications on any of the pathogens or any of the human challenge faced by the humanity. Within 6 months, there has been already 67,000 publications in the public domain. That means how much grave concern it is, how much people are focusing on this COVID-19 pandemic. The good news for that was yesterday when the ChAdOx1 vaccine trials were out. The first clinical phase trials were out by the Jenner Institute in the Oxford University, which is actually the AstraZeneca is running that clinical trials. And they had come up with some hope that the vaccine has not shown any side effects. It is safe to use, but there is long way to go about it. This slide gives you the history of the SARS-CoV-2, where it from began and where we are right now. So SARS-CoV-2, as we all know, it has a 30 kb genome, which has only 4 OAPs, which give us the structural proteins, right? The spike glycoprotein it has, which we call as the S protein. Then we have the small envelope protein, that is E protein, the metallomatrix protein, that is M protein, and the nucleocapsid protein, that is N. In order to understand the vaccine development or the genesis of the vaccine, we need to understand the structural biology of the virus as well. The spike protein binds to the interaction of the host cell and the virus we need to understand, and most of the speakers had talked about it, that the spike protein binds to the host receptor via the receptor binding domains or RBDG region of the angiotensinogen converting enzyme 2, which is present mostly in the pneumocyte type 2 cells, which are actually the macrophages within the lungs. And then there are many other cell types within the body, because we are at still initial stage of the COVID-19 research, and we don't know exactly what is the fate of other 2,900 proteins, where they are involving and with which cells it's interacting with. So we are in the preliminary stage here, despite having 70,000 publications about the COVID-19 research. The AC2 protein has been identified in various human organs, not only the respiratory system, that is type 2 pneumocytes, but also in the gastrointestinal tract, lymph nodes, thymus, bone marrow, spleen, liver, kidney, and brain. That means in primary as well as in the secondary lymphoid organs, these cells are present and the receptors are present on them. So the chances are there that this virus can interact with them. Once the virus enters the host via the mucosal membranes, it travels through the respiratory tract and enters the lung alveoli. Inside the alveoli, SARS-CoV-2 binds specifically to the ACE2 receptor present on the type 2 pneumocytes. And it's why that we are having this COVID-19 primarily as a lung disease, although it can impact or infect any part of the body, because the new research on what is pouring on, we are here and there after every week seeing that there are new research findings that it is present, it can infect all, it can spread to all parts of the body, and so on and so forth. This slide talks about the life cycle of the coronavirus, how the SARS-CoV-2 interacts with the ACE2 receptors. Then there is a fusion, endocytosis, followed by the replication of the virus. Then there is the synthesis and exocytosis. Then these are viral particles are released and the new cell are being infected. And in this way, the patient suffered. This is again a slide which talks about the viral replication and the protective immune response in the host by the SARS-CoV-2. The most important part about this virus is that if we want to develop a vaccine which should be successful in the future, we need to generate the IgG response, that is IgG antibodies, that is as a part of the humoral response. And also we need the cell-mediated immune response, that is the T cell response. which is needed for the long-lasting memory so that we can be prevented from this deadly virus. If we talk about this, there are certain things what happen in this COVID-19. First thing is that it is not only the lung infection, it is attacking almost all the organs of the body. Primarily among them are the lungs. It can go to the heart, it can go to the, pathogenesis can go about to the kidneys and to the brain and to the many organs as well. And the story is unfolding till date. We know that there needs to be a delicate balance between the host immune response and the viral pathogenesis. Neither too much of the immune response is needed, because if, for example, we are saying that the cytokine storm is there, it's not the virus which is causing this, but it is the body's immune response which is causing this cytokine storm, and because of which there is most of the pathogenesis in COVID-19 patients. When we talk about the SARS-CoV-2 replication, we know that this is an RNA genome, and the genomic replication process is error prone. We also know that. And then this generates mutations. So a lot of mutations are being generated here and there. This brings us to about the two very important phenomena of antigenic shift and antigenic drift. As we know that the antigenic shift may occur by reassortment of an entire single-stranded RNA between human and animal virions infecting the same cell. So we have two viruses, for example, virus A and virus B, and they are infecting the host cell. Intermixing of the RNA can take place, and we can have a new virus particle, which we name as a virus C or a different type of strain. This is explained, this is a viral shift. For example, in case of the H1N2 and H3N1, if the two virus particles are infecting the same cell, we can have a number of different viral particles or strains in case of the influenza. The same is case with the antigenic drift, which is actually a natural process. Antigenic drift may occur by accumulation of point mutations over a period of time, which eventually yields a variant protein that is no longer recognized by antibody to the original antigen. So that belongs us to the antigenic shift, which is explained in the diagram, as we can see all from here. This talks about us that the alarm was there, the signal was there that there may be a next generation pandemic in terms of the flu, because this is also a flu type vaccine. This is a coronavirus, it's an RNA-based virus, and it has similar homology with that of the H1N1 influenza virus. If we talk about the Spanish flu in the 1918, it was again come in 1957. This slide, I'll be talking about the later part of the challenge of my presentation, when we talk about the future challenge in terms of the COVID-19, in terms of the development of the vaccines. Variations in the strains had been there. The influenza strain is an example before us, that there has been different strains, different variants, which has come across during different time periods. And till now, we have different variants coming up. Then there are the chances of there may be pandemics in the future as well. Why to talk about a vaccine? We know at present scenario that there are almost more than 14 million people who are infected, and every day we are having more than 260,000. If we talk about the yesterday, 261,000 people were infected across the globe, and the recovered among them is the 8 million, and we had almost 603,000 deaths from this. And if we talk about the India, we are at number 3 right now in terms of the infection, and although the number of deaths is less, because we had the infection reached to this to our country in later part of the it reached from the Europe, not directly from the China. It gave us a little bit of time. Then there are other theories floating here and there, because we are already infected with the various environmental mycobacteria. We are immunized with the BCG vaccine, and many theories floating around here and there. And immunologically, we are a superior race, and so on and so forth. But that need to be validated through the scientific data, and scientific data need to back those claims. So when we talk about the vaccine, we had a variety of vaccines. In vaccines, actually, what we are trying to do, we are trying about a particular pathogen, whether it may be a virus, it may be a bacteria, or it may be a fungi or something else. When we want to reduce the immunogenicity, we may change the actual nature of the virus or the pathogen need to be changed. It can be done by many ways. Either it can be done by attenuation, it can be done by heat killing, it can be done by treating the particular virus or the particular bacteria with different type of chemicals, or it can be done by interchanging the different types of hosts. It's why that we can have attenuated vaccines, we can have whole inactivated viruses vaccines, we can have live attenuated vaccines, we can have recombinant subunit viral proteins. For example, if we talk about here in the COVID-19, we have a S protein and we have E protein and M protein and N protein. So if we want to have a vaccine against this COVID-19, we can use the subunit vaccines, we can use the recombinant vaccines, we can use the live attenuated vaccine, or we can use the inactivated vaccines as well. Strategies are here discussed how we can make that. So that is not the part of the topic. The topic is how the vaccines are currently in developmental phases, what is their fate, and how they are being developed. If we talk about the viral, this representation about the mechanism of action of a vaccine, whenever there is a viral antigen entering the environment, it's being taken usually by the professional antigen presenting cells of the body, here being the pneumocytes type 2 in terms of the lungs, or it may be the Kupffer cells or any other type cell in the liver and so on. Then these chop down these antigens, either the viral proteins or the viral antigens. Once those are chopped down, they are being loaded on the MHC molecules, then presented to the T cells in context with these self-MHC molecules. And after that interaction, there is production of the B cell T cell interaction is there. Once the costimulatory signals are there, then the B cell gets activated and it converts into plasma cell. Plasma then produces a lot of antibodies. This is the normal way. And similarly, if the T cell and this TH cell and the cytotoxic T cell or CD8 T cell interact with each other, then the CD8 cell gets converted into the cytotoxic T cell, which can then produce the interferon gamma or perforin or granzyme B and cause the lysis of the infected cell, which is then it reduces the viral load. But in both the cases, it has to be the memory cell for the long-term generation. Usually, we know that once after 5 to 7 days, there is primary immune response is being generated. It takes 5 to 7 days. Then there is a peak for almost 1 week of those antibodies within this. Then the antibodies had not to be about it may be the IgGM or IgG antibodies, but for memory purposes, we need IgG antibodies for long-term protection. Usually after 6 months.
Dr. B, 2 minutes, please.
Okay. So here is a rush towards the vaccines. If we talk about yesterday, only once the Hydroxychloroquine vaccine trials were out, that the UK secures about 90 million doses of potential COVID-19 shots. Now, as the purchase of the Oxford vaccine as well, the vaccines had already signed the agreements with the Biotech and Pfizer, a German firm, for about 30 million doses of the vaccine. Similarly, from the Valvina, a French-based pharmaceutical company, 60 million doses. And then they are now with the AstraZeneca, which has already signed a deal to produce 400 million doses for the US and the 100 million doses for the UK if it is successful in human trials. So there is a rush to get hold on the vaccine candidates, to get the vaccine so that your population. This slide talks about the various vaccine candidates and their clinical stats. If we talk about, there are a lot of vaccines. Some are the whole cell based vaccines, some are the subunit vaccines, some are RNA based vaccines. Here we'll be talking about some. This is the WHO's draft landscape of COVID-19 candidate vaccines, which was released on 20, that is yesterday, they were released, that these have been given approvals by the different regulatory agencies across the globe for going for this clinical phase 1 or clinical phase 2 trials in their own countries. This the list continued, and there are almost 142 vaccines which are in the pipeline. Then America has started an Operation Warp Speed, OWS, in collaboration with several US federal government departments, including that of the health. NIH is there, NIAID is there, or National Institute of Allergy and this infectious disease is also there. You can we list the agencies like HIV vaccine trials, HIV prevention trials network, infectious disease clinical research consortium, and the AIDS clinical trials group. They had roped in almost all the government and private agencies in order to develop a vaccine and some drugs for treatment of the COVID-19 patients. The US government is choosing 3 vaccine candidates to fund for phase 3 trials under Operation Warp Speed. One is the Moderna's vaccine. One is a US-based company, that is the mRNA 1273 vaccine, which the trials will begin in the July itself. The University of Oxford and AstraZeneca's, that is the ChAdOx vaccine, AZ122 is the official name for that. They are trying to go for the phase 3 clinical trials in the August itself. And then in 3 countries, mostly in the South Africa, then UK and Brazil, they are going for the testing of the phase 2 and phase 3 clinical trials. Then Pfizer and BioNTech, BT and 162 in the September, they are planning to go for the phase 3 clinical trials of this vaccine in late September. If we talk about the ChAdOx, the good news for the human race was yesterday when the first report of the clinical trials was published in the Lancet medical journal, and it was reported that there are no side effects to this ChAdOx vaccine, although it was given to a small population and almost 1,100 patients and these volunteers it was given. And it's a vaccine which is based upon the rhesus macaques. The first initial trials were done on this rhesus macaques monkeys, and then the human trials began in the April, May month. Then the results were out, which were published yesterday. And the key takeaways for that were that the results of the first clinical study of ChAdOx vaccine, the vaccine was safe and tolerated with reduced reactogenicity when paracetamol was used prophylactically for the first 24 hours after vaccination. So immunization with ChAdOx1 results in rapid induction of both humoral and cellular immune responses against SARS-CoV-2 with increased responsiveness after a second dose. So then if we talk about the Covaxetin, if we talk about the whom, where the domestic, in India is also trying to focus on the 2 indigenously produced vaccines. One is the vaccine with this Covaxin, and another vaccine is with the Zydus Cadila. They are also trying to ZCoV-D vaccine. So both the vaccines are under clinical trials. The DGCSI and as well as the ICMR has given the go-ahead to this Covaxin vaccine. It's being made by the Bharat Biotech, is a Hyderabad-based pharmaceutical company, and presently the Genome Valley in Hyderabad, where they had established a containment facility, that is a BSL Biosafety Level 3 lab, where the presently trials are going on. And in addition to that, we are having the Zydus Cadila, which has also started human clinical trials, but has not divulged much of the information into the public domain. But about the
Dr.
Covaxin,
Mir,
we know.
Dr. Mir, please conclude.
Yes, just one minute more. So the Covaxin vaccine, which has been developed by the Bharat Biotech, the 3 hospitals had been roped in. It is the AIIMS Patna, then PGIMS Rohtak, and then the specially preventive and therapeutic clinical trial unit, which was established in the Bhubaneswar. The clinical trials are going to start from the 22nd. And we hope that with these many vaccines, then we are having many vaccines being developed by the Chinese companies like Sinopharma. Then we have the mRNA COVID-19 vaccine, mRNA 1273. Then we are having CoronaVac vaccine by Sinovac from China again. CoronaVac, this CureVac mRNA-based vaccine by the German pharmaceutical company. Then again, IBP CoronaVac virus vaccine by Sinopharm China again. Then SBP. These are simplifying some are the RNA vaccines, some are the subunit vaccines, and some are the inactivated or heat-killed vaccines, or some are the attenuated vaccines which are being looked. But most of the people here, they are talking about the BCG, why Indian subcontinent is not affected too much, because 1/3 of the world population is already infected with the Mycobacterium tuberculosis bacteria, and we have used, and the BCG is the vaccine which has been given to more number of people on the planet Earth than any other vaccine, and we have already taken doses of this BCG vaccine. It's a Mycobacterium bovis strain, which is used against the Mycobacterium H37RV strain, which causes infection in the humans, and it has given protection to good levels. But the protection is not universal, as we have seen that in Petrolu, we are having least protection, but in the Europeans, there has been good protection for this BCG vaccine against the Mycobacterium tuberculosis. So future challenges are there. If we take about the influenza virus, this is my last slide, that if the first human influenza virus was isolated in 1934 and was given the subtype designation as H0N1. This subtype persisted up to 1947, when a major antigenic shift generated a new subtype H1N1, which supplanted the previous subtype and became prevalent worldwide until 1957, when the H2N1 emerged. Then the H2N2 subtype prevailed for next decade and was replaced in 1968 by H3N2. So antigenic shift in 1977 saw the reemergence of H1N1, again the original subtype. The most recent antigenic shift in 1989 brought the reemergence of H3N2, which remained dominant throughout the next several years. However, an H1N1 strain emerged in Texas, USA in 1995, and current influenza contains both H3N2 and H1N1 strains. So with each antigenic shift, that the two important antigens, surface antigens, that is the hemagglutinin and the neuraminidase, undergo major sequence changes, resulting in major antigenic variations for which the immune system lacks memory. So thus antigenic shift finds these populations vulnerable, that there can be many more outbreaks. We really don't know, being as the genetic makeup of this is RNA, so it has an RNA genome, and which is more prone to the variations. Nobody knows that whatever we are making the vaccines against in present times against the surface antigens, that is the 4 antigens which we have, but that tomorrow may change, or the viral strain which will be emerging after some time, and that may lack those antigens in the vaccine, may not work. So nobody knows about the future of these vaccines as of now, because keeping the influenza example in view, we maybe have. So the most important thing at present is that we need to go for not the social distancing, but the physical distancing from each other. We need to wear the masks. We need to go and take the precautionary medicines when the symptoms, mild symptoms develop in a patient, and keep the other, those vulnerable populations, like who had other comorbidities, need to take care of them. And hopefully we, with the grace of Almighty's and all our prayers, we may overcome this pandemic. Thank you so much. If there are some questions, so I will be much more happier than to take some of them. Thank you so much.
Thank you, Dr. Mir, for expressing so many things in your talk. And I'm sorry that because of the time constraint, we could not listen it in a even more descriptive manner. But you had prepared the slides very nicely. In the last, that what you have said is really the conclusion, the main take-home message, that the vaccine, though the several countries are generating, including our own, can be useful for protecting us from the SARS-CoV-2 infection. But there is, of course, a doubt that it can provide or it cannot provide 100% protection. Exactly. because of the mutations taking place off and on. Regarding the mutation, this is a slow mutation going virus because of the presence of the exonuclease activity into its genome. So that is one point, but still the mutations are going on, and that is why the vaccine trial, vaccine production efforts, I am really not having very surety of it, that it can be useful to protect the masses from the SARS-CoV-2. Further, if I am not sure that what kind of strains or the pathogenic strains have been selected country-wise for production the specific vaccine against it. So can you please highlight one or two points regarding the specific strains which have been selected in India for producing the vaccine?
The
Dr.
strain,
May.
yes, the strains which has been used by the, for example, if we talk about the Chadox-1 in UK-based vaccine, it's based on the influenza vaccine, and the spike proteins had been taken from the SARS-CoV-2. If we talk about the strains what has been used in India, these were the local strains. It's not the strains which have been taken from some other country, but it was the National Institute of Virology who had isolated those strains, and then these strains isolated by the National Institute of Virology locally has been used to generate the vaccine candidates.
So for generating the vaccine, you are taking some portions, for example, the S1 domain from the spike protein, glycoprotein,
Not in
or
Indian
some
case,
part.
not in Indian case, but in case of the Chadox they had taken. Because Chadox is a combinatorial vaccine, they are using the S1 domain as well as the influenza causing virus.
Yeah, because in this case, I am sure that those who are involved in this process would have taken into consideration that the highly conserved regions, which are synthesizing the proteins, maybe nucleic acid or membrane or the spike proteins, would have been chosen for the vaccine generation. So thank you so much, Dr.
Exactly.
E, for enlightening us with your beautiful illustration in the lecture. And with this, I thank you once again, and over to Dr. Ishwarya.
Yes. Thank you, sir. I would like to thank the chairman, sir, for such a nice chairing of this technical session today. And again, I would be very thankful to all the speakers for today who have been given so informative and fruitful information to our audience. Okay, now I request Engineer C.J. Wesley, Joint Registrar Administration, for the University Prospective. Wesley, sir, over to you.
Thank you, Dr. Shodra. Respected speaker and dear participants, it was an enriching experience for all of us to listen to our learned speakers during the course of this international webinar. I am sure that everyone here has gained deep understanding on the topics that have been shared yesterday as well as today. On behalf of our Honorable Vice Chancellor and the University, I extend our sincere thanks and gratitude to all the speakers, the participants, and all who have contributed in this insightful webinar. We received an overwhelming response of more than 2,000 registered participants who witnessed this webinar. I would like to inform you that all the videos of this webinar are available on our official Facebook verified page, that is SHUATS, and our official YouTube channel, Connect SHUATS. Dear participants, your certificates are ready to download on our university website, that is www.shuarts.edu.in/BCBE certificate. You can sign in and download the same using your credentials, that is your email ID and the mobile numbers, which you have used in the registration process for this webinar. Sam Higginbottom University of Agriculture Technology is an institution with a remarkable history of 110 years now. The institution has served with the motto, serve the land and feed the hungry. I would like to inform you all the admissions for various undergraduate and postgraduate programs offered by the university for the session 2020-21 are open now. We currently offer 47 undergraduate programs and 110 postgraduate programs. Please do visit our official website, shuarts.edu.in, for more details. I'll shortly share you, you can note down the web link for downloading the certificates, your participation certificate, that is www.shuarts.edu.in/BCBE certificate. Shortly, you will receive a thanks email from the organizing secretary along with this link so that you can readily download your certificates. I would like to congratulate Professor Dr. Viru Prakash for taking up this webinar at the right time with the right topic. I wish you all very good health in these testing times. Stay home and stay safe. By the grace of Almighty, we will definitely overcome this pandemic together. Thank you so much.
Thank you, sir. Okay, may I now request Dr. Sushma for a vote of thanks. Ma'am, over to you.
Thank you, Dr. Yashodhara Verma. Respected eminent speakers, participants, faculty members, it is my privilege to propose a vote of thanks on this occasion. I, on behalf of University Administration, the entire team together, and on my own behalf, extend a warm gratitude and sincere thanks to all speakers for gracing this event with their cerebral words and esteemed presence. Undoubtedly, each one of us has been benefited by your valuable content presented during this international webinar on the title and theme COVID-19 Pandemic Crisis and Aftermath. Further, I take the opportunity to thank Honorable Vice Chancellor, respected Pro-Vice Chancellors, Directors, Director IPC and Dean JIBB, Registrar, Joint Registrar for providing this platform and facilitating all required facilities and encouragement to make this webinar event. I would also like to thank all the participants from India and abroad who have registered for this international webinar, and I'm sure that have been benefited by the talks delivered by the eminent speakers for these 2 days. It is my pleasure to thank Head Department of Biochemistry for his support and continuous guidance and inspiration to organize this webinar. I'm happy to thank all the committee members from Department of Biochemistry and Biochemical Engineering for their continuous support and untiring support to make this webinar a great success. I fully acknowledge their nimble participation. I'm thankful to all non-teaching staff of the department for their tireless help. Last but not the least, I am highly thankful to all media personnel for giving a big publicity to this international webinar. I thank one and all. Thank you. Over to you, Dr. Yashodhara Verma.
Okay, ma'am. Thank you, ma'am. Now, due to scarcity of time, we'll not be able to take up the report of the webinar, but instead, I would like to invite Professor Alok Milton Lal, sir, for closing prayer. Alok, sir, over to you.
Thank you, Yashodhara. Thank you for giving me time. Let us pray. This is the time that we should devote our time in prayer and thank God for all the information that we have collected. Heavenly Father, we thank you and we honor you. Father, what insight we have received today and yesterday, Lord, this is from your wisdom, this is from your insight, this is from your grace. Heavenly Father, I pray, I thank God for all the resource persons, Lord, those who have shared their knowledge with all our students and colleagues, Lord. Heavenly Father, I pray, give them more wisdom, give them more knowledge, Father, so that your name will be glorified through their lives and their works, and especially, Lord, in the area of this vaccine development and in the area of drug development, Lord, that the scientists, those are working hard. Lord, I pray that when you will give your wisdom, when you will give your knowledge, when you will give your understanding, then only things will come into the right direction. Heavenly Father, the whole generation, the whole mankind is looking at you, and we all are looking at you, Lord, that you will definitely give us a way, and you will make this world again calm and better and a good, Lord. Lord, we commit each and everything into my hand, and especially I commit our chairman, sir, also, those who have worked hard and who really you helped us, Lord. Help everyone. Bless us in Jesus' mighty name. We ask this prayer. Amen. Amen. Okay.
Thank you, sir.
Over to you.
Thank you, sir. Okay. With this, we come to the end of today's webinar. Thank you all.
Thank you very much.
Saming Bottom University of Agriculture Technology Sciences, signing off. Jai Ishu, Jai Hind, and Jai Bharat.
Jai Bharat. Jai Hind.